So let me just bombard you with lots of examples. So hopefully after a while you get a sense of what's going on. So suppose you want to work out the volume of this solid here. So here you've got you would rotate it here. So this is like an area of a circle here. Here you would rotate it all the way around here to form a circle. So if you look at the area of cross section, so this is our f of x here. This is our f of x here. This diagram is our cross section. So if you want to work out the area of this solid here, you would get the radius here. So get the height from here to here, and then so once you've got the radius here, which will be f of x. Once you've got the radius, then pi r square it. So that will then give you the area of this disk. Okay, and then you would move along, and then do it again here. So for this one here, it would be so for this one here, it would be from here up to here. That would be your radius, and then pi r square it, and that would then give you one revolution here. Well, that would then give you all the way up to here. Okay, so that would then give you the next disk, and then you would continue all the way to the end here. So this is your end here. So this would be your end here. So once you've got the radius here, you would pi r square it. That would then give you the whole disk. That would give you the area of the whole disk here. Okay, so in effect, what you're doing is you're summing up all these disks here. So don't forget, when this here at the moment is just a radius. When you pi r square it, then that will give you the whole area of the disk, and then you would sum up all the disks. So in effect, what you're doing is you're summing up all the disks. So pi r square it. So you this here would give you the area, but then you would need to times with the dx. But then from here, in effect, what you're doing is you're summing up all the disks. But then the fundamental theorem of calculus 1 allows us to jump to the integral. So really, we are taking the integral from, let's say this is a here, let's say this is b here. So we are taking the integral from a here to b here. Okay, and then this will be well, if you look at the width of this disk here, it will be dx. So this is your dx here. The point I'm trying to make is that to work out the volume of this solid here. Oops, hang on. To work out the volume of this solid here, you would take the integral from a to b. So this is from a, and this here is b. That's this a here. That's this b here. Okay, so b here, a here. Don't forget to take the area of the circle. So it will be pi r squared, but r happens to be f of x here. And then don't forget, you're summing up all the disks. So the width of this disk here would be dx here. So this here would be dx. So to work out the volume of this thing here, you would need to do this. Okay. So for the next one here, so you might have to press pause and really think about this solid here. To work out the volume of this solid here, so this is the blue line here is this blue line here. Okay, and the green line here, is this green line here, and then from A, so this is A here, and this is B here. I haven't shown you this method yet, but I will do in due course. But it's easier to sum up all the disks like this, as opposed to this. So it's easier to do like this. So if you look at B here, so B from here to here, so that's from here to here. So don't forget, you have to somehow find a way of finding out the whole disk here. So that's you doing this. Hang on, that would be you doing this. So that will then give you the area of the whole disk. But then you've got to take away the area of this small disk. then that will give you the donuts here. You're interested in this ring here, this donut-like ring. Okay, so for the first disk here, you well, to do this here, you should sum up all the disks here. Okay, so first start to work out the volume of this thing here. Don't worry if you don't understand this. I will show you how to do it another time. But briefly speaking, it will be from A to B. Okay, and don't forget, if you're summing up everything in this direction here, the thickness of this disk here will be dy. Earlier was dx, but now because we're doing it horizontally, the thickness here is dy. So this will be something dy. Now you will need to work out if you look at B here, you've got to work out the whole disk and then take away the smaller one. So the green line. Okay, so to work this out here, hang on. To work this out here, you would have to get from here to here, which is the green line here. Somehow you've got to work out the x direction of you have to work out the x direction, the x distance from here to the green line. So you might have to rearrange it to get the distance from A to from here to the green line. So hang on, it's easier if I just do it rather than trying to explain it. So it will be you working out the disk here. So that will be, well, you need to know this distance here. Let's call this distance here g for the green line. So it will be pi r squared, but r happens to be this g here for the green line. So it will be, hang on, AB, it will be pi green line squared, take away pi, and then take away blue, the distance from here to here to the blue line, blue squared. Okay, so if you this here will let's look at this bit here. When you do this bit here, you are in effect working out the area of this circle here. Okay, and then you take away you take away this bit here. So that would be this bit here. Okay, so this bit here would be the small area here. Would be this small area here. This bit here is like this big area here. So what you've got here is a ring. What you've got here is a ring. So this will be dy here. It's hard to explain this, but in effect you're summing up everything. Okay, so and also I made a silly mistake. I used this to represent the blue line here, and I also used B to represent this limit here. So just take that into account. Okay, but briefly speaking, to work out this volume here, you would have to do this. Okay, and don't forget G. So somehow you've got to work out the distance from here to G. This B here, you've got to work out the distance from somehow get the distance from here to here. Okay, so roughly speaking, it would be something like this. It doesn't matter if you don't understand it. I will explain how you do this another time. I've only shown you how to do it vertically. I haven't shown you how to do it horizontally yet. Okay.